Hi friends, welcome back to my channel. Today we are going to discuss about Bland Altman Plot. If you are new to this channel, please press the subscribe button and click on the bell icon to get notified. Bland Altman Plot or Bland Altman analysis is a commonly used method in the biomedical research. This method is used to study the agreement between two measurements that are in continuous scale. Bland Altman analysis is widely used for quantifying the agreement between two quantitative measurements, and this is done by constructing the limits of agreement, and this method was introduced by Bland Altman in 1983. J.M. Bland and D.G. Altman introduced the method, and this is called as the Bland Altman analysis or Bland Altman plot. Why we have to use Bland Altman plot? Because the correlation and linear regression will give us something about the bivariate relationship which exists between the two sets of measurements. Using this, we can identify strength, form and direction of the relationship, but this approach is not suitable for comparative analysis. So that's why we have to use Bland Altman plot for the comparison measurements. Bland Altman plot is used to detect presence of systemic difference between the measurements or possible outliers. So before going to the plot details, we should understand what is bias and when it is measured. So bias is the systematic error related to a measurement. That means that how much the result differ on average from a reference. And the purpose of estimating bias is to get knowledge of the systematic error. So when bias is evaluated, so bias is evaluated or calculated during these cases when we are introducing a new methods or instrument, or to check the consistency between parallel instruments, or to check the performance of new lot of reagents, to check changes in the performance over time. So in all these cases, we have to evaluate bias or the systematic error. So bias can be fixed or proportional. In case of constant bias or the fixed bias, one value can be used to describe the bias throughout the measuring range. But in case of proportional bias, this is not possible because it varies over the range of concentration. So instead, we need to take or define bias as a function of concentration. So across the concentration, we have to measure and define the bias. So now we know what is bias, and let's see how to construct a Bland Altman plot. So the practical example will be given in the next video. In this, let's understand what is the plot look like and how we can construct the Bland Altman plot. For constructing Bland Altman plot, we have to first calculate the difference between measurements of method and method B. Let's say we have two different methods, or you have a reference method and a comparative method. For example, if you are measuring weight using two different weighing machines, or the blood pressure measurement using two different systems, one will be the standard or the method A, and the other one is the method B, which is the new method. First, we have to calculate the mean of the measurements of method A and B, and then we have to calculate the limits of agreement. In the limit of agreement, we have the lower limit of agreement and the upper limit of agreement. Generally, this is mean difference minus 1.96 into standard deviation of the difference for the lower limit, and for the upper limit it is mean difference plus 1.96 into standard deviation of the difference. So why 1.96 is because of the 95% confidence interval. Once the limit of agreement is calculated, we can plot the scatter diagram with mean on the x-axis and difference on the y-axis. Once that is done, we can include the mean of difference and limits of agreement, both the upper limit and lower limit. Once this is done, we will get the plot, and if the data points are very close to the zero line, it indicates that there is a good level of agreement between the two methods. The data points far from zero line indicates that there will be a weak agreement between the methods. So if the data points are aligned close to the mean of difference, then it is said to be with good correlation. Whereas the data points far away from the mean of difference indicates weak agreement between the methods. If the constructed limits of agreements are within the clinical acceptable difference, the two methods can be used interchangeably. So this is basically to compare two different methods and to analyze or to check the data points which are falling within the limits of agreement or not. For example, if you are introducing a cheaper measuring technique in the diagnostic field, whether you can replace the costly instrument. That is what we want to know. Measurements will be taken from both the instruments and compared using the Bland Altman plot. And if the results are matching, the data points are within the limits of agreement, then cheaper machine can replace the costly one. So that is the idea about the analysis using Bland Altman plot. Hope you are clear with this topic. If you like the video, please press the like button and share it with your friends. Thank you.